Welcome to Study Loop.
In this problem, we have been given that there is a wheel and the radius of this wheel is 31 centimeters. That's 0.31 meters. And it is also given that this wheel is able to accelerate from 240 rotations per minute to a speed that is 360 rotations per minute in time interval of 6.8 seconds. So here we observe that the initial angular velocity is 240 rotations per minute. So we convert this into radians per second by multiplying 240 with 2 pi and dividing it by 60 to get in seconds. This gives us 25.12 radians per second. And similarly, we can figure out the final angular velocity by multiplying 360 with 2 pi and dividing it by 60. We get 37.68 radians per second, and the time is given to us as 6.8 seconds. So we need to determine here the distance that a point on the circumference of this ring will move. So basically we need to cover the distance moved by this. So for that, we will figure out first the angle traced, and we can utilize that idea to get the linear distance traversed. To get the angle, we can make use of the kinematic equation omega plus omega naught by 2 times t. So when we take the average of omega and omega naught and divide that by 2 and finally multiply that with the time, we get the angle traced here as 213.52 radians. And we know an expression that relates the angular displacement with the linear displacement, and that is theta is equal to L by R. So L here is the linear displacement which we need to figure out. So we multiply this angle, that's 213.52, with the radius, that's 0.31. So we get here the result as 66.1912. So approximately up to 3 significant figures, we can say that the length of a point traveled will be 66.2 meters.